So in my last couple of videos, I've been talking a lot about factoring and using the quadratic formula, completing the square, all these different methods of solving quadratic equations and expressions and functions, but when do we actually use each of them? Because there's a lot of confusion in seeing a quadratic and knowing the different methods, but when to actually use and apply them. So in this video, I'm going to be talking all about not how to solve quadratic equations, but which method to use to solve them. Okay? So indicate using Q for quadratic formula, C for completing the square, or F for factoring which method would be best in solving each scenario involving quadratics. So number one, Justin wants to solve the roots of the quadratic y equals x squared minus 2x minus 63. So this is your standard quadratic equation, right? We have y equals x squared minus 2x minus 63. First thing we always ask ourselves when we have a standard question like this with quadratics is, can we factor it? So factoring is just getting it into two brackets such that we start with x, and the numbers that we're adding or subtracting, they multiplied this last number, negative 63, and add to negative 2. So negative 63, let's look at the factors here. I'm thinking negative 7 and 9, or 7 and negative 9, because those are both 2 apart, and one of them is going to add to negative 2. So when we add these, negative 7 plus 9, that's positive 2, so it's not that one. Positive 7 minus 9, or plus negative 9, that's going to be negative 2. So that's the one we want. Okay, so it's going to be negative, so x minus 9, x plus 7. And to solve this, just quickly, we know that y is going to be 0 when we're solving for the roots. So equals x minus 9, x plus 7. And since these are multiplying to equal 0, that just means x minus 9 equals 0, x plus 7 equals 0, or both of these is happening at the same time, which it's not for this question, but x is going to be 9, right? Adding 9 on both sides, x is going to be negative 7. So for this one, we would write F for our answer. We would be factoring, right? Because it's just a classic standard equation that we can factor. It's going to be quicker than using the quadratic formula or completing the square. And keep in mind, we're going to get the same answer no matter what method we do. It's just a matter of which one's going to be faster. And notice how this method was super quick. We just thought of two numbers that multiplied to negative 63 and added to negative 2. Bingo bango, we're done. Number two, Jellyfam Dan. Jellyfam Dan's a great basketball player. He's a great YouTuber as well. Go hit him up. Go subscribe to his channel. So anyway, he jumps up for a slam dunk in which his height follows the path of the equation h of t equals negative 4.9t squared plus 6.2t plus 0.1. So that's what we're really interested in, is for any time t after he jumps off the ground, we're going to be able to plug that value in for t and get out his height above the ground. So let's say we're looking at his height 1 second after he's jumped. Okay, so that means that our time is 1 second. We're going to plug that in where we see t, and we're going to get some value h out of that. That's our output. So we're trying to figure out how long it takes him to reach the ground again. So let's just draw this out. We know that 0.1 is our y-intercept. So if, actually, let's say we got Daniel right here. Right, we got Daniel right here. He's got the basketball. He's balling. Right. Got a basketball hoop over here, right? Nice little hoop there. I know I'm an artist. Try and hold your applause. And we got the hoop here. Hoops like this. And for whatever reason, we know that he's 0.1 meters off the ground when he starts at time equals 0. So that means that from here to the ground is 0.1 meters for whatever reason. Maybe he's wearing extra thick shoes to make himself look taller. That sounds like something he'd do. So maybe that's what he's doing. So let's say he starts here, right? He's jumping up to do the dunk. Obviously he's missing because I'm blocking that, throwing it into the third row. But again, that's besides the point. So he's jumping up, he's hitting the ground, and boom, this is where he hits the ground, right here. Right? So that's where his height is 0. That's where h of t equals 0. So we're trying to figure out when h of t equals 0, so h of t equals 0, what does time equal? How long does it take him to hit the ground? If we know he's going up and up and up and up and up, and he's hitting the ground right here after I block him, how long is it going to take him to go from here to here? What is that time? Okay, well, we can figure that out, and I'm just going to quickly go over this. That's not the point of the video. But we can do this by graphing this here, right? So if this is our h of t axis, this is our t axis, so this is t, this is h of t, right? And this line is going to represent where Daniel's feet are above the ground. So we know he starts at 0.1 meters above the ground, and we know he's going to jump in the air and land right there. So the definition, like literally of being on the ground, is just like not being above the ground. So your height above the ground is 0. So that's right here. That's where he hits the ground. And this point right here, this point T, that's going to be our answer for our roots, right? If we're trying to figure out when he hits the ground, we just have to find the roots of this function. And we're only focused on the positive roots because notice how if we go to the left side of the h of t axis here, right here, this is going to be a negative time. And we're not really worried about what Daniel did before he jumped. We're only worried about where he is or how he ended up at this point here, how long it took him to go from time equals 0 to time equals whatever it, like whatever the time was for him to reach the ground. So for all these questions with kinematics or projectiles or anything practical that involves time, we're typically going to reject the negative answer. So what are we going to do? Are we going to complete the square, factor, or use quadratic formula? For this one, we're going to use the quadratic formula because in this case, we have a bunch of ugly decimals. And anytime you have ugly decimals like this, fractions, sometimes you can get away with factoring or completing the square, but anytime you have ugly decimals or really big numbers, typically you're going to use the quadratic formula. And some people will say, well, can we simplify that at all? And yes, we can, because h of t does equal 0, right, when he's on the ground. So negative 4.9t squared plus 6.2t plus 0.1. That's our equation. If we multiply both sides by 10, because all these decimals, they're just to the 10th place. So if we multiply both sides by 10, we get 10 times 0 on the left, which is still just 0. So 0 equals negative 4.9t squared times 10. That's going to be negative 49, so the decimal's gone there. Plus 6.2 times 10, that's going to be plus 62t. And then we got plus 1. So this is the same thing. And even though the decimals are gone, we still have big numbers. And like I said, anytime we're dealing with big numbers, we're not going to be able to factor something like this. Like, maybe we can, maybe we can't. I'm not even sure if there's a real solution. But if there is, it's going to take a heck of a long time to try and think of numbers that are going to work. And maybe we could do factoring by grouping or completing the square, or not completing the square, the box method. But my point is, quadratic formula, it's going to be a lot quicker just to plug in these numbers A, B, and C than to actually think intrinsically and intuitively like how we could solve this without using the quadratic formula. There's not a whole lot of point to doing that. So your answer for this one, we're going to write Q for quadratic formula. Number 3, Evan's going into solder and he wants to sharpen his business skills. He sells soccer balls for $55 to an average of 31 buyers, but he wants to know how to price them such that he'll produce the maximum revenue. So right now, in this moment, he's selling soccer balls for $55. And when the soccer ball price is $55, he can expect to sell soccer balls to 31 buyers if the price stays at $55. But the question also says, provided that every $3 increase in ball price loses him one customer, what price should he blah, blah, blah. So every time he increases the price by $3, he can expect to lose one customer. That's what the first half of that sentence is saying. So if he starts at 55, let's say he increases it once. He does a $3 increase. So now his new price is $58. If he does a $3 increase to $58, that means he can expect to sell balls to one less customer. So we started at 31. Now he can expect to sell balls to 30 people instead of 31. Okay, let's say he does that again. Let's say he jumps from 58 to 61. So he does two $3 increases. That means he's going to lose another customer. He's going to lose another customer. It's going to be down to 29 customers, 29 buyers. So this question is all about optimizing the ratio between number of customers and price. Because anytime you increase the price of something, it's going to lower the number of customers you bring, typically. And anytime you decrease the price, it's going to increase the number of customers you bring because people want to buy cheap stuff. So this is all about balancing that ratio. And this is going to relate a lot to what I talked about in a previous video called optimization. We're trying to optimize how much revenue, how much money we can bring in for a set of given initial and adaptive conditions. So we have the initial $55 and 31 buyers, and we know for every $3 increase, he can sell balls to one less customer. So this is going to be an optimization problem, okay? And if you want to know how you could solve this problem, just go back to my other video and it explains it in great depth. So we could solve that using completing the square. Actually, I'll just write that here. So this one's going to be C for completing the square, getting it into vertex form. Okay, let me just see here. Paula wishes to graph the function a of r equals 2r squared plus 5r plus 3 by hand and as accurately as possible. She recognizes that using a equals 2, b equals 5, and c equals 3, she can determine the y-intercept of the graph as well as the vertex using x equals negative b over 2a. Okay, that's a lot of wordy stuff. Let's just break this down here. So we have this function a of r, and it's just a classic quadratic equation. Let's actually just write this in terms of y and x. So we could just write this y equals 2x squared plus 5x plus 3. And the second sentence says, she recognizes using a equals 2, b equals 5, and c equals 3. What does that mean? Well, a is just the coefficient on the x squared, b is the coefficient on the x, and c is our constant, our number at the very end. So all this means is a corresponds to 2, b corresponds to 5, and c corresponds to 3. And from those numbers, we can determine the y-intercept and the x-coordinate of the vertex, and then later the y-coordinate. So the x-coordinate of a vertex of a parabola, that's just negative b over 2a. We find this using calculus, but I'll derive this in another video. So the x-coordinate of the vertex is going to be negative b. We know our b corresponds to 5, so it's going to be 5 but negative over 2 times a. A is going to be 2, right? That's what corresponds to a. 2 times a, that's going to be 2 times 2, which is 4. So this is the x-coordinate of our vertex. We can plug that in for x to figure out what the y is, or in this case, a of r. But anyway, that's what the first two sentences mean, is she knows that, she recognizes that using a, b, and c, we can find the y-intercept, and by the way, that's just going to be 3. It's always our constant, our last number. And we can also find the vertex. But how can we find the roots of this equation? Because she's trying to graph it by hand as accurately as she can. And if she only knows the y-intercept and the vertex, that's going to give a decent representation of the graph, but it would be even better if we knew where the roots were. Okay, so if we know where the roots are, it's going to look a lot nicer, a lot cleaner, a lot more accurate. We can connect the dots a lot nicer. So how could we solve this to find the roots? Well, like in the first question, we have to ask ourselves, can we graph this? Because can we factor this? Because if we can factor it, it's going to be really pointless to use a quadratic formula or complete the square for something that we can factor in probably 30 seconds. Okay, so if we want to factor it, like I said in the first one, that means we can get into two brackets, right? And instead of writing x and x, the variables have to multiply to 2x squared. So one of them is going to be x, but the other one's going to be 2x, because these have to multiply to 2x squared. Okay, and the numbers we're adding or subtracting, they do have to multiply to 3 still, but they can't add to 5, because we have this 2 in front of the x squared now. It's going to mess up that method. Okay, so if we look at the factors of 3, right, it's going to add to positive numbers. So it's either going to be 1 and 3 or 3 and 1. So it's going to be x plus 3, 2x plus 1, or vice versa, x plus 1, 2x plus 3. Let's see if this works. This is going to be 2x squared, like I said. X times 1 is just plus x. 3 times 2x is plus 6x. 3 times 1 is plus 3. So this is going to combine to 7x. We don't want that. We want it to add to 5x. So that must mean that we have to switch the order of our 1 and our 3. It's going to be x plus 1, 2x plus 3. Because now x times 3 is 3x, and 1 times 2x is 2x, okay? And that's going to equal 5x, and that's exactly what we want. So in this case, we would factor, and that's factored correctly. But like I said before, this video is not to tell you how to solve these equations. It's just the method that we would use to go about solving them. So for this one, it would most certainly be F for factoring. And that's only because we can factor it pretty easily using like box method or factoring by grouping. But let's say this was plus 1. I don't know if there's a real solution to this, but if there is, we're not going to be able to do it by factoring, because if we put, like, the only real thing we can do is put like plus 1 and plus 1 in here, or minus 1, and neither of those combinations are going to give us plus 5x back. So if it's like some weird number that we can't immediately factor, I wouldn't recommend factoring. I would probably use a quadratic formula. But if it's something that we know we can factor, we kind of intuitively sense that that's an available method, then that's what I would go with. But like I said, it's not bad. Like, it's not really looked down on to just default to the quadratic formula for harder questions. But for ones like this, where they're ones that we can obviously factor, factoring will be a lot quicker. And I know teachers are kind of obsessed with forcing you to factor, not use your calculator, but lots of the times it's honestly quicker, because if we recognize we can factor this right away, instead of putting like negative b plus or minus the square root of b squared minus 4ac over 2a, that takes a long time. If we factor this and set each bracket equal to 0, we can probably solve it in 20 seconds. With a quadratic formula, it'll take at least a minute or two. So it could save you a lot of valuable time, just knowing which method to use. And I hope this video gave you some intuition into how to choose between the three kind of main methods of solving quadratic equations. So thank you for listening, and I'll see you in my next video.